Okay. Suppose the measurement error x of a certain quantity has the density function given below. Determine k. So we know that the integral from negative infinity to infinity of f of x has to be equal to 1. And in effect, the only non-zero part of it is from -1 to 1. So it'll be -1 to 1 k times 2 minus x squared. That has to be equal to 1. So the k is a constant. Pull that out. Integral of 2 is 2x. Integral of x squared is x cubed by 3. Integral from -1 to 1. That's equal to 1. So put in the upper limit. 2 times x is 2 minus 1 by 3 minus -2 minus -1 cubed by 3 equals 1. And all this simplifies to 10 by 3. So k times 10 by 3 equals 1. So k equals 3 by 10. So that's how we get this 3 by 10. And then they say find the probability that a random error is less than a half. So we want the probability that x is less than a half. So that's done over here. Probability x less than a half would be the portion of number line less than a half is negative infinity to half. So it'd be integral negative infinity to a half fx. But this can be broken from negative infinity to -1 because from negative infinity to -1, it's 0. And then from -1 to a half, it's something else. So that's why we break the integral from negative infinity to -1 and then -1 to a half. So this part is 0. And then from -1 to a half, it's k times 2 minus x squared, but we already determined that k is 3/10. So 3/10 times 2 minus x squared. Once again, the integral is 2x minus x cubed by 3. Now the limits are -1 to a half. Once you put those and work with those, you end up with 0.788. And now the somewhat new part that find for this probability, for this particular experiment, it's undesirable that the magnitude of the error, that is absolute x, exceeds 0.8. What's the probability that this occurs? So we want probability absolute x is greater than not 8, but 0.8. And now, so let's just rewrite it again. But okay. X greater than 0.8. Now, absolute value is easier to handle if you go the other inequality. So we will use the complement rule to convert probability of x greater than 0.8 into 1 minus probability. So absolute x greater than 0.8 equals 1 minus probability absolute x is less than or equal to 0.8 again. 8, but 0.8. And the reason is that we know that if absolute x is less than or equal to a, that means that x is between negative a and a. So what we really need is probability x, 1 minus probability x is between negative 0.8 and 0.8. So now let's open another window. So we are after probability x is between negative 0.8 and 0.8, or 1 minus that. So this would be 1 minus the integral from 0.8 to negative 0.8 to 0.8 of fx dx. Now, negative 0.8 to 0.8 falls within this interval, -1 to 1. So it's 1 minus the integral negative 0.8 to 0.8, and the function definition over there is k times 2 minus x squared, which is 3/10 2 minus x squared dx. Pull the 3/10 out. The integral is 2x minus x cubed by 3, negative 0.8 to 0.8. So this is 1 minus 3/10 2 times 0.8 is 1.6. This is minus 0.8 cubed by 3. And then minus the lower limit. 2 times negative 0.8 is negative 1.6 minus negative 0.8 cubed by 3. And when I simplify all that, let's see what I get. So 3.2 minus 2 times 0.512 divided by 3. 2.3. 1 minus the answer. So I get 0.1424. 0.142.